Well, hello everybody and welcome to this CIRCASA webinar. So today we're going to present our project's Work Package1, who is strengthening the research community and structuring knowledge. Thank you for registering, and I'm going to present today panelists. So today we have three panelists. First, we're going to have a presentation about Peter Smith. He is our Work Package1 leader. He's Prof of Soils and Global Change at the University of Aberdeen in Scotland, UK. Then we will have a presentation of Andy Bray. He's a research fellow specialized in biochemistry and environmental mineralogy at the University of Leeds, also based in UK. And last but not least, we're going to have a presentation of Jan Verhagen. He's a senior scientist specialized in agricultural systems, carbon cycle, and climate adaptation of the Wageningen University and Research, based in Netherlands. So these are our three panelists. After these three presentations, we will have a short time to answering all your questions and to have also a discussion with you if you're interested. So for the people who is the first time in a webinar, I'm just going to explain you some webinars rules. So if you want to ask questions, you can use our chat room tool at the left of the screen, or you can also use the Q&A tool. So you can ask all your questions there, and we have a little time at the end of the presentation to have a discussion and answer all your questions as far as possible. So now, Pete, I give you the floor. So let's start with this webinar, and thank you again all to be present here. Please, Peter.
Okay, thank you, Seri. So can you all see the screen now? I'm hoping that that's visible to everyone. So as Seri just mentioned, I'm the Work Package1 lead for the CIRCASA project. And you can see that this work package alone involves a collaboration between a number of institutions. We'll be hearing from researchers today from Leeds and from Wageningen as part of the work that we're doing. So I'm not going to give a long presentation. I'm just simply going to set the presentations that you're going to hear from Andy and Jan in the context of the overall work package, because we're not covering all of the work package today, just two key aspects of it. I'm trying to move on. There we go, on to the next screen. So the Work Package1 is about strengthening the research community and structuring knowledge, and it's structured around three tasks, and we're mainly going to hear from tasks 1.1 and 1.2 this morning. So 1.1 is stock taking and linking research networks and projects. So what do we know about the research that's currently going on? There's lots of research that isn't part of CIRCASA that's going on presently and has gone on over recent years that are very relevant to the topics that we're covering in CIRCASA. So we're trying to link all those together so that we can stand on the shoulders of all that excellent research that's going on and that has gone on recently that's relevant to the project. Task 1.2 is collaborating with networks and projects identified to review the scientific and technical evidence and to draft the science base for the project. And that's what we're going to talk about a bit today, having put together, consulted with the experts in the field, put together what we know and what we think the main areas that we need to do and to research in this project. The ones that we won't hear so much about today are the task 1.3 and 1.4. 1.3 is the research synthesis activities to provide georeference data sets that come from a range of different sources. So this is a way of combining data sets and getting them together into a common format so that we can use them together in a spatial georeference format. And 1.4 is to create a pilot knowledge information system from that data that links the soils, the climate, and the agricultural practices. So whilst there are some of what you'll hear about today is relevant to tasks 1.3 and 1.4. Most of it will be centered in tasks 1.1 and 1.2. So I don't need to say any more now. I'm going to hand over to Andy. Andy's then going to be followed by Jan. They'll talk for about 15, 20 minutes. We'll collect questions on the way, and we'll just have very brief clarification questions, which we'll try to answer as we go through. If there are any remaining, we'll deal with those at the end of each presentation. But if there's anything more generic, we'll try and save that for a discussion session at the end. So thank you, and I'll now hand over to Andy.
Hi everyone. I'm assuming that you can all hear me, so hopefully this will work. So welcome. This is some work that we've been doing as part of Work Package 1, where we've essentially been trying to understand where the state of knowledge is with respect to soil organic carbon, and what we know, what we don't know, and what we know we don't know, and what we don't know we don't know. So it's a little convoluted, but here you go. So this is some work that I've been doing here in the Earth Surface Science Institute at the University of Leeds. But this work has also involved a lot of other people who have contributed both to the initial creation of the questionnaire that we sent out to academic researchers and to industrial researchers, and also the subsequent creation of some testable hypotheses for future research directions. But I'm going to start a little bit big picture. I'm not sure who's in the room, so it's good to contextualize this. Soils are one of the largest pools of carbon on Earth, and actually when you normalize it to the volume, they're the most concentrated carbon pool on Earth, even greater than all of the crustal carbon. So things like all the limestones and fossil fuels that are in the crust. Soil has a greater concentration of carbon per volume. It's also got a really, really quick turnover time, or average turnover time, that mainly is interacting with the atmosphere. And we estimate the soil organic carbon stock to be somewhere in the order of 1.5 to 2.4 thousand gigatons of carbon. And soil organic carbon is really important for the health of a soil, both to soil structure, water retention, nutrient cycling, and just the existence of terrestrial life. And generally we can look at this as quite simply just being the fixation of carbon from the atmosphere through photosynthesis, and then this being exuded into the soil through roots, and also through the decay of roots and leaf litter during a plant's life. And for the last 12,000 years that we've been really driving agriculture forward as humans, we've lost around about 116 gigatons of soil organic carbon. So that equates to somewhere in the order of 7% of the existing soil organic carbon that we have today. So that kind of gives the impression that soils are this depleted sink of carbon that could potentially be used to offset atmospheric emissions of carbon dioxide, to minimize greenhouse gas driven climate change. And this is the idea behind the 4 per mil initiative. If you're not familiar with this isn't a graphic that I produced, but this is from the 4 per mil initiative website. But essentially the drive behind this idea is that if we can increase the amount of carbon that we are able to sequester in soils, if we can increase the amount of soil organic carbon, we can do something towards offsetting atmospheric emissions of carbon dioxide, and try and halt climate change. And soils are really important for other reasons as well. You know, there are at least 5 of the Sustainable Development Goals put forward by the UN that are directly related to soil, both in terms of food production and health. Soils are also important for clean water, and also for climate action, and for all of life on land. Soils are key. So it's almost like soils are in this unique political situation at the moment, where there's need for soils to be made great again. So I'll let you just laugh at that for a moment. But this is a great soil profile that's from the Wageningen Soil Museum. If you haven't been, it's a great visit. So we looked at the literature on soil organic carbon research and on agricultural soil organic carbon and the way that it cycles, and we identified 14 challenges to future research towards soil organic carbon. And these we divided into 3 themes, generally based on fundamental processes of understanding how soil organic carbon is created, processed, and stored. Basically, the processes that occur in soil that control soil organic carbon dynamics. Then some challenges around the way that we use the soil, that we manage land, and we interact with the soil to understand how soil organic carbon changes as a result of our action, but also how we can measure and monitor and predict soil organic carbon through changes in land management. And then some larger scale challenges around socioeconomic, institutional, legal issues to do with the way that we view soil and we treat soil from both a legal and economic and social point of view. So we took these challenges and we created a questionnaire that we put out to researchers across the globe. We distributed this via personal networks, through social media, things like Twitter and LinkedIn. And we gathered a huge number of responses. It was fantastic. I'm sure that some of you in the room responded to this. And in total, we got something like, yes, it was 211 responses through the time that the questionnaire was live, which was about 2 months. And these responses, we gathered some demographic data about the respondents. So we got some information about expertise, so what their area of research expertise was in, where they were based, so their region, where their knowledge was based, so their regional knowledge, some idea of the scale of their expertise, so going from subplot, so less than a meter, up through plot, farm, regional, and then through to continental. And also we gathered some information on gender distribution as well. So we got responses from all of the continents that we're farming on. We didn't have any responses from any of the penguins, which is a shame. But I'm not sure what they know about soil organic carbon in particular. And our regional knowledge spans the globe as well. And it was really good to see a good representation across the planet. Again, we had a good representation across scales, probably skewed towards plot and farm, which is likely a result of the focus of many of our respondents on agricultural practice and soil management and land management. What's interesting is that we had a really poor representation of social science disciplines in the respondents to this survey. So only one respondent who identified economics as an area of expertise. And this maybe says something about the reach of our research networks. Myself and the other guys who were pulling this together, our expertise is mainly in biogeochemical cycling and more fundamental natural sciences. So possibly there was a skew there in terms of the distribution that we were able to, the distribution of expertise that we were able to reach. But you can see that we have representation across multiple disciplines within soil science. So there's some information on the demographics. What I think is really interesting is thinking about how these people both rated our knowledge of our understanding of different topics, the different challenge topics, and also the rating that they gave them in terms of importance for future research in soil organic carbon in agriculture. So here are the results. This is a busy slide with lots of information on it, but basically I'll talk you through it a little bit. On each of these graphs, we have, on the y-axis, we have the number of counts, so this is frequency, against a rating of 0 to 10. 0 being we have no knowledge, and 10 being we as a community know something completely. It's interesting that in a number of these questions, actually all the questions, we have responses for each of them which are ranked as 10. We didn't collect any data to identify who was responding to this. I wish we had now, because there are some people who ranked every challenge with a 10, and I'd love to email them and just get their knowledge, just suck their knowledge out of their brain. But you can see here we have each of the different topics. These are listed here, A to N, and I've just given a little label to each of these graphs to give an indication of what they are. But you can see generally we have distributions which are positively skewed. So we as a community tend to think that we know quite a lot about these ideas, about these concepts. And there are those that we have a negative skew off. So our understanding of deep soil carbon is we as a community think that we know very little, or tend to think we know little about this. And then there are some which have a normal or bimodal distribution. So there might be multiple groups of people within our respondents who have differing views of our level of understanding of these different topics, or topics that maybe our respondents don't really know that much about, and so weren't able to accurately respond to them. We also asked the respondents to rank each of these challenges in terms of importance for future research, and these were ranked as first to fifth in each of the different groups, apart from the final theme, which was ranked first to fourth. And you can see a distribution across the different challenges of rankings. One thing that's really interesting is that this challenge F, which is measuring and monitoring soil organic carbon, received both the highest number of first ranks and fifth ranks. So respondents viewed this either as the most important one in this theme or the least important one in this theme, and that's a really interesting response to observe. But we can weight each of these rankings by multiplying them by a number 1 to 5 in reverse. So a first rank gets a number 5, and a fifth rank gets a number 1, and then we can sum these together. And so you can see that we have a weighted ranking here in these second graphs, which shows some prioritization, at least from our respondents to these different topics. It's quite difficult to see in this view, but here we can look at it as their relative importance across the themes. And here I'll just put the challenges in order of importance. So most important overall were the economic barriers to implementing soil organic carbon sequestration methods during land management. Then the second one was our understanding of the stabilization and cycling of soil organic carbon, so the fundamental soil dynamics. Third, socio-cultural barriers and challenges around implementing soil organic carbon, and these are varied and varied based on region as well. So things that happen in North America might not necessarily be the same as things that are pressuring things in Europe, or even South America or Africa or Asia. Fourth was the importance of microorganisms in controlling soil organic carbon dynamics. And in this sense, we've also been thinking about macroorganisms, so soil organisms in general, but mainly soil invertebrates. And then we have 4 topics which are all around about the challenges around managing soil, so vegetation management, using mixed agricultural practices, preventing soil organic carbon loss, and measuring and monitoring soil organic carbon for understanding changes in soil organic carbon as a result of management changes. And then the relation between soil organic carbon and the different greenhouse gases that are also associated, so the cycling of methane and nitrogen and the production of nitrous oxide and other greenhouse gases is also ranked in this one here. And then we have the use of organic amendments and how we can use these most effectively. And then the legal and institutional barriers that prevent soil organic carbon or soil carbon sequestration practice adoption. And then deep soil organic carbon, soil carbon saturation, and then the technological readiness that we have for implementing soil carbon sequestration. But it's interesting to think about where our ranking, our importance, where we rank, the relationship between how well we know something and our rank of importance. So I did a little analysis to see whether there was a relationship between how much we know about a topic and the importance of that topic that we have ranked in this questionnaire. And this can really be divided into three groups, or two or three groups. So first, those that are positively skewed, in which we see the more that we know about a subject, the more that we view that it's important. So our perceived knowledge correlates with our perceived importance of a topic. There's also those which have a normal or bimodal distribution, where we have this inverse correlation between our perceived knowledge and our perceived importance. So maybe we don't know about something, we don't know about something, and so we don't understand the importance of it. And then the third group is this one group, which was the deep soil carbon, which was ranked. This is the only one which had a negative skew, a negative distribution in terms of responses, and we know very little about it. And this is our third least important in terms of what came out from the questionnaire. So that leaves us with a couple of questions. Around about what this might mean. So we know that this is probably a result of respondents' areas of expertise, but could it also be a symptom of past funding? Have we been funding the wrong things without necessarily thinking about what might be important at a larger scale? Or is this simply just an issue with cross-discipline communication? So those disciplines that are all working on soil science, not necessarily been able to understand the relevance of each discipline's work to the dynamics of soil organic carbon and the way that we use land. So after this questionnaire, we're taking this information and using it to at least attempt to prioritize a series of cross-discipline testable hypotheses. And these hypotheses are going to be spanning the scale of the challenges that we were looking at in the questionnaire, from molecular scale processes and fundamental science through to the institutional and economic constraints that we have in actually implementing some of the agricultural practice that we are able to drive forward as well. And so we're looking at driving these hypotheses forward with the mindset of offsetting atmospheric anthropogenic CO2 emissions, and then also helping agriculture to adapt to a changing climate, and in doing so, improving productivity and food security, and developing sustainably as part of the UN Sustainable Development Goals. So this is me. I'm going to finish now. I think we might have some time for some clarification questions now. So I'll see if I can have a little look at those. Let me see. Okay, I can't see any questions at the moment. So I'll hand over to Jan, who Jan is going to be talking about our understanding of our research network, who are trying to tackle soil organic carbon, or who are working on agricultural soil carbon and offsetting atmospheric CO2 emissions as well. Jan, over to you.
Okay. Mm-hmm. I'm just hoping this works, so if it doesn't work, does somebody shout. I will talk about the task 1.1, which is about, as Pete already said, on the networks and projects. I will be more talking about the networks based upon the meeting we had in Cali. Then I talked about Plan B. I indicated, in fact, in Cali that I was moving to Plan B, so I'm sure that everybody's aware of this. We'll use the projects as collected by EGP, so I'm not going to report on this. We limit the search now to scientific literature. So it's going to be very basic because we didn't get much response to the questionnaires we send out. And Kali had a few questions. We agreed upon the focus on scientific output only. We're still not sure about the added value, but it is something that in fact reflects very well on what Andy just presented. So let me take you to what we did. We look at science to policy and science to science and science to practitioners and business. Science to science is something that Andy, in fact, just presented. So my main focus is on the policy and the stakeholders and how we can find added value from this analysis. So we focus on institutes. We also had an angle to look at people because they are very critical, some people in these networks, and they actually dominate part of the discussions in science, but we can only do it on institutional levels, otherwise it will become too vague. The gaps in research on the 4 teams I'll present after this slide, and to identify complementary networks. So where do we go wrong and where can we get some information from? These were the main objectives we had, only based upon scientific literature. Now the conclusions, that's for me is always the easiest thing to present then. It is the CIRCASA network as such has a bias to soil processes and soil management. We seem to be very good on the basic processes, also linking to nitrogen processes and soil management, mainly at farm and field management, or plot, if Andy is, as Andy presented it. These soil science networks are poorly linked to social and farm research domains. There's a lot of things going on outside this domain that we're working in, and they're not very strongly linked. And the implementation issues, adoptions and barriers, these are the institutional, financial, cultural, but also skills of farmers, seem to be not very well studied in relation to carbon sequestration. So there's still, science is lagging there. There could be different reasons for that. I took 4 categories, so I split monitoring and management. I took them apart. So I have the processes, that's the understanding of the processes. I've got the monitoring, actually measuring it at different scales. The management, how you can actually stabilize or increase soil organic matter. And then the implementation and the barriers. And I put all these categories together because the hits were very, very low. We look at 3 target groups in terms of who can use that information. Farmers, that seems the obvious one. I left out science here, as I said before. Policymakers and the private sector. These are the key target groups that we gear towards. We had 4 steps in the approach. First, we looked at all the papers that address carbon sequestration in soils in relation to climate change or greenhouse gases from 1999 onwards. And then I look within that selection at the 4 teams and at the 3 stakeholder groups. And then we had another idea to look at complementary networks, and that was data taken from 2015 onwards. That was basically the Paris Agreement started there. So we had a different time slice also to get some difference in results and focus. If you go for the first results, it's pretty basic. If you look at all papers that relates to agriculture, soil organic carbon, climate change, you get a very high hit, 14,000 plus. And this was in mid-April. If you look at soil processes, and soil processes has to do with accumulation of soil organic carbon, soil biota, biology, soil farming processes, soil fertility, and soil physics in relation to soil organic carbon and climate change, you get 1200 plus. So about 9% of that whole vast amount of information that is there in science deals with that topic. There are a lot of papers that refer to soil carbon sequestration in the abstract, but then continue on nitrous dioxide, for instance. That's one of the bigger things in agriculture. Soil monitoring is even lower. That's 6.4%. The management is reasonably high if you compare it to the rest, and the barriers is the lowest ones. That's what's said in the conclusions already. If you look at the stakeholder groups, the surprising part here is that it is a lot of things are about management, but they're not per se to do with farmers. That could be that sometimes farmers are seen as a private sector or an enterprise. That could be a pollution there. But for sure, they're not geared towards policymakers. And while policymakers are the main donors or sponsors of this sort of research, there seems to be very low interest in targeting this group. That was a surprise for me. The private sector, we have again companies, business, industry, enterprises as sort of other words we look on in that group, and farmers are smallholder farmers, family farmers, that sort of thing. So we had a broader sweep there. If you look at CIRCASA partners for the teams, we seem to be doing rather well, or if you like, in the policy arena with 10 or 9%. But again, with the barriers, this is compared to the other hits of the all literature on these themes. So there you see that CIRCASA, which is a small segment of that group. So I think there's 22 partners in CIRCASA. So we have the similar sort of bias, but not so much on the monitoring. We seem to be doing very well on monitoring as compared to the rest. The same for policymakers. There, CIRCASA seems to be very strongly focusing on policymakers as compared to the main sort of group. So we're doing better there, if you like. So the bias to soil processes and soil management is there. Soil science networks are poorly linked to the social and farm domains. And these are the conclusions I already said earlier. The implementation and adoption of barriers are not well studied. That's a tricky thing. A lot of the research is now coming out actually, so it's relatively new also. But it's not per se only related to soil organic carbon. So let me continue with the research networks we have. Now this is, I hate these maps, but people seem to like them. But anyway, that's my problem. The yellow dots are the CIRCASA network. They're more to the left. To the right, that's more the Asian dominated literature, which is very large. In fact, if you look at the size of the balls, the circles, it's pretty well dominated by CAS, and even CAS is in there somewhere, and a lot of Chinese universities. They're very active on this topic, which is good in a way. If you look at CIRCASA, they have a very good footprint, but there are some things missing. I didn't look at countries because it was not always very clear, and it will take a lot of time to get all these institutes out and allocate them to a country. We had a look at that, and China is obviously dominating. I'll get back to that. So if you look at the number of publications per institute, so not per country, and then I only have now I listed in the report only the institutes with more than 30 publications since 2015. The orange sort of star there is the first CIRCASA member that is listed in that group. The first one is the Chinese Academy of Sciences, and the Graduate University of Chinese Academy of Sciences, which is basically the same. USDA, and the Northwest Agricultural Forestry University. And then we've got the first CIRCASA member. So we're not that bad as CIRCASA, if you like. But it is much dominated by the Chinese, if you like, and then you got some European and Northern American groups. If you look at the citation impact, which, I had to scale it, but that goes up to 5 over here. This is much dominated by the French groups and Canadian. Agri-Food Canada is there, CIRAD, IRD. University of Aberdeen has a very good score there. And you see the other institutes also coming down and then on the list. But also this group is dominated by French and European and then Northwestern and Northern American institutes. If you then go into the barriers or adoptions, I'm not showing you everything because I only have 15 minutes, which I'm already almost over, I guess. If you look at publications on barriers or adoption, it seems that Ohio State University, with about 19 publications, is doing well there in that sense. Probably linked to one person. I didn't go into the literature itself because it's undoable with all these numbers. The other thing is that it's more a mixed bag. So India, China, Brazil, and then Europe, and then Australia. So it's a bit of a mixed bag, but the numbers are low. So it's not really determined. That landscape is not really solid yet, if you like. But if we want to do something with barriers or adoption, we might want to start looking at Ohio State, and even might go to the Indian Council of Agricultural Research and check there. Policy making, that's 2015. That's not very surprising in a way that the French have a very strong focus there with the 4,000. I think it's defining the landscape there again. The numbers are very low, but very distinct, that a lot of French institutes are working on this topic and actually looking at policy making. I didn't go into the details what they actually are looking at, so that is something I'm not sure. Could be on legislation. There are some papers coming out on legislation nowadays and how it hampers certain implementations of manure types, etc. So, conclusions for B, very simple. The publication numbers and the information might provide an indication of focus of donors or governments, and the pool of scientists, because if you have the scientists, you can put the numbers there. So there's a combination. But I think that there's a donor signal there as well. So we will see that part of the adoption and barriers will increase. It will not necessarily pop up in the CIRCASA network because we're not linked to that. So we might want to look actively for that. Numbers are dominated in numbers of publications by Asia. The impact is dominated by Europe. France is pretty good, and Northern America. Canada and the US are very strong there. And as I said, Ohio State University stands out in the list of institutes that look at adoption and barriers related to carbon sequestration. There's a vast amount of information on adoption and barriers in relation to agricultural progress, on technologies, etc. But specifically for carbon sequestration, there's not much going on. So I did not go into that. We tried that, but it was not very, didn't get any good results, because most universities, they do have awareness of the idea that there are barriers and adoption problems, but sometimes they're so local, it's very difficult to scale them up. So it's not always that obvious how to do that. So indirect information flows are not included, are not mapped. That is something that's a frustration for a lot of universities and research institutes. Magazines for farmers or end users, websites, even Twitter or any fast moving information over the web is not always documented or mapped. Even in Dutch policy documents, it's not always clear what the sources are. So being able to track down to the actual policy documents and seeing an impact is difficult. So also the impact on the stakeholder groups is not always clear. So it basically becomes very difficult to get that sort of information. Now, if you want to do that, and I know in Verhagen at the library, they're looking at that sort of things because it is part of our sort of aim to have an impact, but we're not there with the tools yet. So we're also stuck with the basic scientific literature, which is not enough to actually communicate with society. So any ideas there are welcomed. So I think this is my last slide. So I give back the floor to Pete, I think.
Okay, thank you very much, Jan. Are there any questions directly to Jan? If so, you can type them into the chat box, or you can type them into the Q&A box at the bottom of your screen. Okay, I don't see any appearing that are directly addressed to Jan. So maybe we could I'll just recap. So we have had a few questions that have been asked during the presentations. The first three were from Carla. Carla asked, how do we see the real possibility of sequestering carbon in the soils with the application of good practices? And I've sent a quick response to that one, saying that there are two things really. There are in degraded soils, or soils that are low in carbon. There are many practices that we can do, that we know about, that either increase the inputs of carbon to the soil, and that could be external inputs like manures or composts, or it could be inputs from the plants, for example, with deeper roots or more dense root structures, or even with roots that are less decomposable. So we can, that's the one way to do it, is we can increase the inputs, and the other way we can do it is to reduce the losses. So that would include things like keeping ground cover, keeping the soil protected from erosion by having relatively dense root networks. It could include tillage, changes in tillage practice, although I recognise that that's controversial in terms of the evidence. So I think there's about 60 plus different options that can be done that can increase the soil carbon. So I think where soil carbon is depleted, we have a lot of options. The other thing to bear in mind is that we have some very high carbon stock soils, particularly in natural grasslands and our peatlands and organic soils. And what we need to do is we need to protect those stock carbon from being lost. That's just as important as increasing the carbon that's in those soils. We have another two questions which are related, which are to do with how quickly we can measure the change, how quickly can we detect the change in soil carbon, and what do we recommend for doing that? The quick answer to that is that we're measuring a small change against a large background. So it's a difficult thing to do. So it can take a while to detect a change against that large background. So we're probably, even with lots of samples, we're probably looking at 5 to 10 years minimum for detecting a change in soil carbon. That the changes in soil carbon will occur more quickly in warmer areas, in the tropics and subtropics, and are much slower in the temperate and boreal regions. So again, it will partly depend on where you are, but we're probably looking at 5 to 10 years to change. And then how do we do that? So there are a few methods out there. There are some old methods which involve titration or loss on ignition, basically where you just you burn off the organic matter and look at the difference in weight. Those are time consuming and less accurate than the modern methods, which include things like commercially available carbon and nitrogen analyzers. These elemental analyzers are now relatively cheap. They use a dry combustion method, and they can give you accurate determination of changes in soil carbon and nitrogen. And if you don't have one of your own, if you're not based in a research institute or a university, you can now get those done fairly cheaply through commercial labs. And the last question that we had on the Q&A was from Eleanor Milne, who asked, are most of the papers from Ratan Lau's group in Ohio? And Jan mentioned that he hadn't done the analysis, but I suspect, given the given that Rattan is based there and he has a centre that's based around carbon sequestration, my guess is that most of those papers would be coming from that unit.
Yeah, I would say that would be most likely the case, but yeah.
Okay, we've just had another question from Afili, which says, hello, we're working on soil carbon monitoring and soil improving cropping systems, the University of Applied Science in Western Switzerland. Is it possible to participate in CIRCASA and in what way? Thanks. Sari, can you answer that one?
Oh, yeah. So I'm working, just a second.
So we have funded partners. I mean, my quick guess is that we have lots of partners who've decided to come on board who aren't funded from the original partnership. So CIRCASA is meant to be an open supporting action. So my guess is that if you can share your details with us afterwards, we can put that to the steering committee, but I don't see any problem with becoming involved. Obviously, there'll be no money coming your way, but we could then share the data and we can share our methods and we can collaborate together on that. Sari, do you have anything to add to that?
No, we could see how we can do this, but we always can stay in touch. So if we can see if there's any possibility to, but I think I have no response for this, me personally. But yes, I propose you to keep in touch, hopefully, and to see how we can do this done.
If I could just say, yeah, there would be direct opportunities straight away. We're pulling together these testable hypotheses, and actually there's some work that we need to do on particularly soil carbon monitoring, and also, you know, actual agricultural practice that that we can do to improve cropping. So yeah, if you could get in touch with either Pete or I, then yeah, there'd be plenty of opportunity for you to get involved instantly.
Yeah, just for information for everybody. So this is going to be recorded and we are going to share the slides also. You can always contact me or the panelists for more information even after this webinar. So do not hesitate to stay in touch with us. Thank you. Yeah, if someone has another question, they can use the Q&A tool, or even they can raise their hand. So if they want to ask their question directly to the panelists, you can we can give you the rights to activate your camera so you can participate to the discussion. So do not hesitate to really ask all your questions. Okay, so if no questions, we're gonna maybe close this webinar if nobody has something to add. I remember you that even if you have questions later, you can always contact us. So Pete, if you have something to add before closing this?
No, nothing to add. Thank you very much for attending. And as Sari said, we are, you know, this will be available for people to watch offline if you want to go back and look at it again, or if you have any questions that occur to you a little bit later that you couldn't think of during the time, please send them through and we'll try and answer them for you. Thank you.
Of course, it is going to be shared also on CIRCASA web page, so don't hesitate to take a look. And I'm going to share all this information also via your mail since you get registered to this. Oh, I see a last question also from Carla from Argentina. Can you, Pete, answer to this question maybe?
Yes, sorry, I was muted. Yes, so thank you very much, Carla. It's great to hear that you're measuring soil carbon content systematically, and we would very much welcome you to stay in touch. So whilst the funding is from the European Union, it is a global network, and we'd very much like to connect with other researchers who are trying to do similar things. So please do stay in touch, and thank you.
Okay, thank you. So that's all for the questions. We're going to close this webinar. Thank you again all for being here today, for attending, for registering, and hope we will see you in the coming webinars. And thank you again. Thank you, Jan, Peter, and Andy for your presentations. And see you at the next webinar. Thank you. Bye-bye.